Yeah. Yeah, let's start. Hi, everyone. So thanks for coming our workshop at the Graphs, our workshop sessions. So thank you for coming. I'm Kinjo from Akindo. Yeah. So yeah, today is our first time English workshop session for the Graph. So yeah, today's moderator is not me. Today's moderator is our team members, Morio. Yeah, Morio is is avatar is a dog. Yeah, green dog. So please, Morio-san, so let's moderate this workshop. And so please, excited this today's workshop event with Kevin from the Graph. Please.
Okay, great. Thank you for the intro, Kinjo-san. So yeah, as Kinjo-san introduced, I'm Mario, business development lead at Kindle. And yeah, so let's start. Hello, everyone. Yeah, and welcome to our fifth WaveHack Global onboarding session. It's very pleasure to have you with us today. WaveHack Global is an exciting prize-funded acceleration program designed to spawn the next great crypto applications by this summer. Our mission is to help you bring your finest product to market. With the support of our top-tier project partners, we provide grants and feedbacks to enhance your products, supporting both new launches and the expansion of existing solutions. The program is already underway, and as we gear up for 3 major demo days in Japan this summer, let's remember why WaveHack Global is the event to be a part of. First, you'll have the opportunity to receive grants from leading global projects like zkSync, Manta, The Graph, Mina, and Aptos. Every 2 weeks, you will get valuable feedback from these top projects judges. And our weekly online study sessions like this are the perfect chance to learn about the latest technologies and in-demand products. Moreover, you have the unique chance to pitch at major crypto conferences in Japan this summer, which are IVS Crypto, EdoCon, and WebEx. Okay, WaveHack Global is an accelerator for global dApps builders, open to all builders at any time, either teams or individuals, free of charge. This summer, you have the opportunity to astonish a broad audience with your projects tailored to our grant partners' themes, pushing towards mass adoption of crypto. Okay, today, we're joined by Kevin from The Graph, who will be leading this workshop later on. The Graph is a decentralized protocol vital for indexing and querying blockchain data used by tens of thousands of developers worldwide. Now let's dive into an engaging session with Kevin and explore how the graph can serve as a foundational tool for your project. Thank you for being here, and let's make the most of this workshop to build something great together. Now, let's take a brief look at the agenda for our workshop today. So, yeah, first I will introduce Kevin, and Kevin will have a presentation about the graph and probably some exciting things. And then we will have a Q&A session. So please feel free to comment anything on YouTube. And at the Q&A session, we will pick as much questions as possible and answer them. And be aware, the graphs build theme at the WaveHack Global is the best new subgraph, which include a total of the 10,000 US dollars grants. So this theme challenges you to build and deploy a custom GraphQL API that indexes data from a smart contract. It's an opportunity to not only contribute to the graphs ecosystem, but also to showcase your technical prowess and innovative thinking. We're excited to see what you will build and how you will leverage the graph to push the boundaries of what's possible in the blockchain space. Let's make this session productive and insightful. Okay, Kevin. Now, without further ado, let's welcome Kevin to share his insights and expertise with us. Kevin, thank you for joining us today. We're all eager to learn more about the graph and how we can utilize it in our projects. The floor is yours.
Awesome. Thank you so much. I really appreciate you guys having me here. Thank you. I'm saying hello from San Francisco, California. So I'm a little bit a ways away. So as always, it's great to see these great communities all over the world spawn up, and you guys are great. So I think without further ado, I can share my screen and we can kind of get started. Just quick check. You should be able to see my screen now. Is it all good?
Yes,
Yeah?
good.
Yeah, perfect. We can see it.
Awesome. Cool. Well, thank you so much. So today I'm going to be talking about the graph. I'm going to be telling you a basic introduction of what the graph is. And then we're actually going to go into some subgraph development basics. So I'm going to teach you actually how to build a subgraph. My name is Kevin Jones. I'm a developer relations engineer at Edge and Node, which is one of the core developers of the graph protocol. And I'm also one of the core members of the Build Guild supporting Scaffold ETH, which we're going to have a workshop, I believe, next week on Scaffold ETH, which should be super great. I'm going to briefly talk about exactly why you need the graph in a Web3 application or a blockchain application, and explain exactly what the network is, a little bit how it operates, and then talk a little bit about the configurations of a subgraph. Then I'm going to go into and give a demo of how the Subgraph Explorer works, how the Subgraph Studio works, and then how you can actually deploy a subgraph. And then we'll leave some time for questions. So to get started, I want to just kind of start with the basics. So if we can just kind of think a little bit about smart contracts and why they're so powerful and what's so important when it comes to them from a data perspective. So as you know, the network for the Ethereum network is all based on transactions, or any blockchain for that matter is based on transactions. So people want to transmit by sending value between accounts, but they also maybe want to send a transaction to a smart contract, right, by executing a transaction. And if you're a good smart contract developer, you are most likely emitting events, and data is coming out of your smart contract that is basically useful for your front-end application or for doing other things like data analytics, data science, maybe AI and machine learning. There's lots of interesting ways that you can take this data and use it over the historical time of a blockchain's life or a smart contract's life. And so these smart contracts are very useful when configured properly. So we could take a quick example of the CryptoPunks NFT. So everyone's heard of the CryptoPunks, these little like JPEG images of punks that are maybe overpriced depending on how you look at it. If you have a punk, it's kind of a status symbol, but really it's just an NFT. And under that NFT is information about every single punk in the terms of what the punk's ID is, so what its index is, and then who the current owner is of the punk, and then where all the metadata sits for the external off-chain data, right? Like things like the traits, the image URL, all of the metadata. And it doesn't seem that interesting, but it's actually super powerful because we're dealing with a data structure, a data format. And so that's what smart contracts are, is they're a way to store and keep track of data in a secure way on the blockchain. So what are the problems though? There's obviously issues when it comes to data, otherwise the graph wouldn't exist. So let's talk a little bit about what those are. The first is there's lots of transactions in a block, right? With Ethereum, there's a block every 12 seconds. With some layer twos, there's blocks every few seconds. And so there's people that are interacting with tons of different protocols, sending transactions between each other. And it's very difficult to sift through that over the standard interface, the JSON RPC interface. And it's really a kind of a mess to go through. The other idea around the initial architecture of a dApp is that you have a user interface that you deploy, and you have your smart contract that lives on the blockchain that has all the business logic for your application. And you would kind of deploy your front end code, your HTML, your JavaScript, your CSS somewhere on most likely some kind of interplanetary file system or Filecoin or some kind of file sharing service. And then you put that business logic on your smart contract, and you could read and write. But when it comes down to it, if you want to read data from the blockchain from your smart contract, it's very complicated to get that data in the way you want. And oftentimes you end up having to make multiple requests over and over and over again to get the data that you care about. And in terms of blockchains are more incentivized for writing, right? We pay some gas to put a transaction on the blockchain, but when it comes to reading data, there's no incentivization for the Ethereum nodes to serve the data in a fast, reliable way. You don't pay for that. Reading is free, right? You're paying for your security onto the blockchain. We also have a history problem. We can't get what's called provenance, right? The historical data of what happened on a smart contract very easily. If let's just say you wanted to know who transmitted a punk at one particular time, or who, changed some kind of setting on a smart contract, you would have to know the exact block number, and you would have to go back in time, make a query against that block number to get the data you care about. And that can be very difficult when it comes to data on the blockchain, and you really need a way to index it properly. So what we really want to do is something like this, where we, if anyone remembers Time Machine, it was a feature of Mac that I think is still there, but I don't think anyone uses it, where you could kind of go back in time and get historical data about changes to a specific data format or data structure. And if we think about it from a front-end developer's perspective, this is actually an example of something we saw in the wild, where someone was trying to get all of the NFTs for a connected wallet, and then they were trying to display those in the front end. So using the standard kind of interface approach of JSON RPC, you would need to get the entire number of NFTs in the actual wallet. Then you would have to make multiple requests to the RPC with the IDs and get all the information back and push that into an object. And this is fine if you only have like 1 or 2 NFTs, but if you have many NFTs, like most people do, I think I have like 400 or 500 NFTs in my wallet. This could take 10 minutes for the page to load, which is not an ideal scenario for a front-end developer. So this is where the graph comes in. So the graph is a decentralized network of indexers. So what does that mean? So it's its own network in the sense that there are indexers running all over the world that are taking in configurations that developers write that organize the data into subgraphs. We're going to get more into that. There's 90,000 delegators who are basically delegating stake. There's curators who are basically curating subgraphs that are of high quality. And there's I think there's actually more, I think it's more like 2,000 subgraphs on the network. So it's a little out of date, but there's lots of data available on the graph network, and it is very decentralized, which is very important to the graphs and how it operates. So we serve about 1 billion to 2 billion queries per day, and we're used by some of the major protocols like Uniswap, MakerDAO, Zora. There's many protocols that are built and use the graph every day, and we'll show some of that off in a little bit. And so the idea is the same large amounts of data that's going on in a block. What a subgraph does is essentially organizes that data into what we call subgraphs, right? So if you're a developer that's writing an app, right, you have a smart contract and you want to keep all that data in a subgraph, you write a custom subgraph. Or maybe you're a developer that's just writing subgraphs for existing protocols that are more optimized. You could deploy those and basically make some curation of that. And so all of these different protocols can be condensed into these subgraph buckets. And so what we're left with is something like this, where we can actually just do one single GraphQL query against the data and get all the response backs in just one simple HTTP request. So if you're not familiar with GraphQL, GraphQL is a query language in the sense that you can query for exactly what you want and get back exactly what you need. And the graph uses GraphQL as its main source of getting data. And so what a more modern application looks like today is something like this, where you still have your user interface and you're still deploying your static assets like your HTML, your JavaScript, your CSS on some kind of decentralized network. You're still writing your smart contract to the blockchain so that you have the security that comes with the network that you're deploying to, right? The consensus and all that. But when it comes to actually getting data and reading data, there's just a middleware that we call the graph protocol or the indexing protocol. And so what does a configuration look like? So the main configuration for a subgraph is 3 files. So there is the manifest. You can think of the manifest as a high-level YAML configuration, which is exactly what it is, that defines all the data sources and exactly where those data sources need to be processed in the underlying WebAssembly that runs. So imagine you have a manifest that says, I would like to index my smart contract on mainnet Ethereum. Or maybe you're just a developer that's testing and you want to do it on Sepolia. You would define Sepolia. Then you would have the contract address there. Then you would have all of the entities, and we're going to show this what it looks like, but you would have all the defined entities that you care about. So the entities are the way that you store the data, the structure, right? It's called the schema. If you're familiar with GraphQL, you've probably heard of a schema before. And then on top of that, you have what are called handlers, which run inside of the WebAssembly. So all of these 3 things kind of work together to basically organize the data. So again, the manifest is the high-level configuration, defines, basically kind of puts everything together. The entities decide exactly what kind of data types that you're expecting in your data that's coming through, and exactly how you want to format it and how you want to organize it into these buckets and make it queryable. And it's all based on GraphQL schema. And then the last one is the WebAssembly. So everything that you do with a subgraph processing is done in what's called assembly script. Assembly script is a subset of TypeScript, so it's very similar, it looks very similar, it's just got a little bit less feature set. But the idea is that you can do WebAssembly inside of a TypeScript-like environment and compile that down and process the data in these, what we call event handlers or block handlers, or depending on how you want to handle the data. And this translates and then stores the data on the network, on the indexers in Postgres. So you have off-chain data, or maybe you have, you have event data that comes in and is being processed, like events from your smart contract. You might also have off-chain data, like IPFS data, right? Stuff you're storing in the interplanetary file system, or Arweave also is supported. You can index stuff from Arweave. The WebAssembly script, assembly script, goes through, pulls that data in based on its configuration, and then processes that and stores it on a Postgres SQL database on the indexer. And then if you're a data consumer, so you're a front-end developer, or maybe you're a data scientist or a data engineer, and you want to consume that data, all you need to do is formulate your GraphQL request to send over your request to Graph Node, which is also running on the indexer. And then the Graph Node is basically doing all of the magic to go out and grab the data that it needs from the SQL server, get the response, and then restructure that and pass it back to you in a nice data format that you can easily consume over JSON. So again, we can kind of look at it like this. If we think of like a DApp is deployed again, probably on like the IPFS network, maybe it's on Arweave, Filecoin, whatever. You're still deploying your smart contract to the network, and you're still emitting transactions to the smart contract. But as that smart contract emits these events, Graph Node, which is the workhorse that basically runs and processes the data, is going to run these WebAssembly mappings for you, take that data, store it into Postgres, and then Graph Node is then going to expose that with a GraphQL API so that you can just query it directly. So it really cuts out this idea of querying the blockchain directly. Not that you can't still do that, but for large amounts of data and for getting this nice data structure, this is the architecture you want to use. Another good option is the Scaffold ETH Subgraph package branch. Now you're going to learn about Scaffold ETH next week, so you might not be able to dive in right with it right away, but it's a good full stack example of how you can build a DApp. And there's a special branch of it called the Subgraph package. So if you search Scaffold ETH and you go to Subgraph package, it's a special branch, just pull that down. There's the existing Scaffold ETH, but it has the graph inside of it that you can emulate with Docker. So it's a really good solution If you want to do everything locally and you want to have a full testing environment all locally, this is a really great thing. And then at some point, you can take your smart contract and deploy it to a public testnet or mainnet or whatever it is. But check out the Scaffold ETH subgraph package. I also did a good workshop on this. So anyone at home wants to scan this. This is a GitHub repo that walks you through using that subgraph package with Scaffold ETH. And there's also a video that comes with it where I did it live. It's about an 1.5 hour long video. So it's a much longer workshop and it's a little more hands-on. But the cool thing about it is you can slow it down on YouTube and you can watch it slowly and follow me along on all my steps that are in this GitHub repo. So this is a really good useful URL. If you want to go there, you can also just go to bit.ly/fullstackdApp, and that will take you as well to my GitHub. My GitHub is kmjones1979. Cool. Let's get into the demo. Enough slides. Hopefully you guys are awake and you guys are excited. I'm very excited to teach you some stuff about the graph. Let's go ahead and first of all, let me just try to get these things out of my way. Gotta hide my meeting controls. There we go. Okay. So when you go to thegraph.com, the first thing you're going to see is this kind of like splash page. It's going to kind of explain to you exactly what the graph does at a high level. Really cool page, actually. It's very, very interesting. But all the important stuff is really up here at the top. The docs is probably the most important thing here. If you go to the docs, there's lots of information in here that talks about how the network works, talks about how to develop subgraphs. But I think the most important for getting started quickly is this quick start right here. So if you go there, it's going to walk you through how to get started deploying a subgraph. I'm going to go through it now, but you guys can read that later. There's a few products that come with the graph. So the first is the Graph Explorer. So if we go to products and go to Graph Explorer is where you go to find all of the subgraphs that are currently deployed on the network, right? So you'll notice here that we have this ability to switch between networks. All of the contracts for the actual indexers for the subgraphs are on multiple networks. Arbitrum1 is probably the one you should probably look at because it's got the most active subgraphs on. People have migrated from Ethereum to Arbitrum1 for the lower gas fees. But what I'm trying to say is you can come in here and search for whatever subgraph you want. So all of the popular ones, as you can see, are on the top because we're organizing them based off their curation. So you can think of curation as like likes on a YouTube video or likes on a Twitter post. This is basically people that have given a little bit of GRT to the actual subgraph to help promote it. So these are all the top most popular subgraphs on the top. So you can see there's one for Uniswap, there's UNCX, there's Compound Finance, there's a few Uniswap ones actually, there's an ENS one. There's lots of different, so depending on if you're going for another bounty, you might want to use one of these subgraphs. But the idea is that you can look at some of these existing subgraphs here and see how they were built, right? So if you want to like click on Uniswap right here, we can actually see exactly how this is built because there's a GitHub repo. So we could look at their subgraph. We can also go to the data and start playing around with the data, which I'm going to get to in a little bit. We'll do this in a little bit, but you can actually query the data here. And it's really an idea for you to see if it's healthy, how many people are indexing it, if it's behind schedule. There's one indexer here that's been out of date for 48 days, but everyone else, there's 12 other indexers that are indexing it. And so you can just get an idea get a feel for the subgraph. But it's really useful to come in here and see, oh, well, how is this subgraph built, right? You can come in and look at the GitHub and then you can actually dive into it. This one is the substreams one, which is a little more advanced, which we're not going to cover today, but it's really, really useful to be able to do that. The next thing I want to show off is the Subgraph Studio. And this is where I think you're going to spend most of your time for the hackathon because you need to, in order to be qualified for the bounty, you need to create a subgraph. So you actually need to deploy a new subgraph based off of your smart contract or based off of an existing smart contract that maybe improves an existing subgraph. So we can connect our wallet here for the first time. You can choose from MetaMask, so you need to have MetaMask installed, or Wallet Connect if you have one on your phone. You can also use Safe if you want to use a multi-sig, and you can use Coinbase Wallet. But we're just going to choose MetaMask here. And it's going to ask you to sign a transaction to prove that you own the wallet. So here we're going to say, yep, just signing it. This doesn't cost any money or anything like this. It's just to prove that you're the owner of the wallet. So, and then the first time you sign in, you're probably going to be asked for your email address, but I already get ahead and did that. And that's going to put you in this free plan. The free plan is really nice because it gives you 100,000 free queries that you can query. You're going to get a development URL to query as well. But in case you want to publish your subgraph to the network and start using it, then you can actually get these free queries, okay? And I think what's most important is you can see all of your existing subgraphs. As you can see, I've deployed lots of subgraphs. I give lots of demos. None of these are actually published, I don't think, to the network, but we can create one if we want. So we could say create subgraph, and we can create one right now. So let's do that. Let's actually go through and create a subgraph. So what I like to do, I always like to come and take a look at something fun we can index. So if you had an NFT project that you wanted to look at, you could also come to Etherscan, and you can go here to top NFTs, which is kind of cool. And we can see like all the popular NFT accounts. We can look at for the past 30 days. So we have like the Bored Ape Yacht Club, Pudgy Penguins. So I always like to do an NFT because NFTs have a little bit more complex data structure. I think I'm actually going to do the CryptoPunks one. So I'm just going to search for CryptoPunks. So we talked about CryptoPunks earlier. It's kind of this really expensive NFT. Let's say, we could come through here and look at the data, and that's very interesting. But when it comes down to it, actually, we can't really get the data easily by just coming here and copy pasting stuff into our application. We need to be able to query, right? So we can see here that the contract's here. We know that the contract exists. We can see that it probably has some transfers that are happening. But how do we get the data, right? Well, this is where the graph comes in. So let's do one on CryptoPunks. So we'll call it CP demo. CryptoPunks demo, right? CP demo. Doesn't really matter what you name it. We're going to create one. So once you create this CryptoPunks demo or any kind of subgraph, it's going to scaffold you out this kind of empty shell where you can put information about what the subgraph is going to be for. You can put the source code, and you should put the source code for where you upload it. And you should also put like your website if you deploy the DApp to production, and you can set tags and then save it if you want. But if we come down here, this is the really important part over here on the bottom right. It's going to give you all the steps that you need to deploy your subgraph. So it's going to tell you step by step everything you need to do to deploy it. So the first thing it's going to say is, okay, well, you need to have the graph CLI installed. So you need to install that. So depending on what you prefer, if you want to use NPM or Yarn, you can do so. So I've gone ahead and did this already. So I don't need to do this, but if I wanted to, I could just copy the command here and I could paste it in. When you install the CLI, you want to do it globally. So you can see here we use the global or the -G flag. This way that it's available anywhere on your terminal later on. So you'll need Yarn installed, and you'll also need, I believe, Node.js installed to do this. So you can copy that, paste it into your terminal. Again, I've already gone ahead and did that, so it's not going to update for me. So I'm going to skip that step. But the next one is just this simple graph init command. So after we have the CLI available, we can run graph init --studio cp-demo. So I can just grab that, and I'm going to go ahead and do that. So when you do this command, it's going to basically ask you, like in this kind of choose your own adventure way, where you can go through and put all the settings in. So first of all, it wants to know what network that we want to index. So as I mentioned before, you can index data from Arweave. You can index data from Ethereum. You can index data from Near, Cosmos, or you could do what's called substreams, which I'm not going to get into substreams, but it's another way of indexing data, which is a little more advanced. But we have a contract that we know that we want to index called CryptoPunks, and we know it's on Ethereum, right? So let's choose Ethereum. It's going to ask you what you want to name it. So probably best practice to name it whatever your subgraph is on the studio. So we'll call it CP demo. And it's going to ask us what directory to create it in. So again, we'll just name it the same, CP demo. And then it's going to ask us all the networks that are available on Ethereum. So we index all the test nets. we index all, well, most all the popular layer 2s. And then we also have like mainnet, right? And we have, you can see here, we have Optimism, we have a number of different of networks. We have all the test nets on the bottom, and you can scroll down through this if you need to. But the one we're going to do is mainnet, right? Because we know it's a mainnet contract. The next thing it's going to ask for is the address of the contract. So if you've deployed your contract to, like, say, Sepolia, you would choose Sepolia, and then you would paste your address in here. Let's grab the address. So we have it here. It's right here on Etherscan. We can grab it. Here it is. Copy it, and we can paste it in. Now it's going to automatically go out, and it's going to fetch the ABI for us. The ABI is the application binary interface. And the reason why it's important for it to do that, is it's going to read in the ABI, and it's going to look and see what events are in the contract automatically for you. And it's going to build out and scaffold out a subgraph for you without you having to do anything. So it's very important that if you are deploying your application, your smart contract, that you verify it on Etherscan or on whatever platform that you deployed it to. Let's say you deployed it to Scroll, then you should verify it on the Scroll scan. If you deployed it to Optimism, then you should verify it on Optimism's Explorer. Then it's going to also go through and fetch the start log. So it's going to look and see, well, when was this contract actually deployed? And that's important too, because if you just deployed your contract yesterday, you don't want to go back in time all the way to the Genesis block of when the network was deployed and index all that data, because there's not going to be any data there. All right, this contract was deployed on block 3,914,495. So we can know it read that in. If it didn't read that in, you could come and grab that. So you could look at the contract, and you could look at the transaction of when it was created right here, and you could find out when it was. But there it is, 3914495. So we know. So let's hit enter and then name it. You can name it whatever you want. The best practice is to name it whatever the contract is named. So if it's your contract and you know how you named it, name it the same. Doesn't really matter too much, but it's just best practice. And then this is probably the most important part, is it's gonna ask you if you want to index all of the events as entities. So in other words, all of your events that are in the smart contract, do you want to build out the schema automatically? Yes, we definitely do. So we're going to say true. It's going to go out. It's going to basically locally build out the subgraph for you. It's going to create a config for the network. It's going to create a GitHub repository as well. And not like on your GitHub, but it's going to create like a Git project. And then it's going to generate a special ABI and schema that needs to be used when you deploy your subgraph for you as well. And then it's going to ask you if you want to deploy or add a second contract. So if you have multiple contracts, then you might want to say yes, but we don't have a second one, so we'll say no. Okay, that's it. So now we can go back to the Explorer, or I'm sorry, the Studio, and we can keep going. So we did these two commands. Now we can authenticate against the Studio. So again, we signed in with our MetaMask wallet into the Studio, so we need to sync that with our terminal. So this is going to authenticate us against that. Go ahead and paste that in. There it goes. So it authenticated us. And then the next thing is to go into the directory. So we can go in there. And then the last one is to do the code gen and the graph build. So if you've made any changes since you first came in here, you would need to regenerate everything. Basically, if you make a change to your smart contract, you want to redo the code gen, and then you want to redo the build. Again, the code gen is just basically doing the types for you, and it's basically building out the subgraph. So we're going to do that. So it's going to go here, build everything for you. It's going to set the API version, and then it's done. So let's take a look before we deploy this. Let's take a look at it. Okay. Okay. So I'm going to try to make this a little big so you guys can see okay. Hopefully this is easy to read. So it is it's a Yarn repo. So it has the package JSON. It also has what we talked about earlier. It has a TS config as well, because it uses TS node, and it uses the subgraph YAML right here. So again, the very first config you ever want to look at with a subgraph is the subgraph YAML. And this basically tells exactly what network we care about, right? So in this case, where it's a mainnet contract, so we care about mainnet. This is the address that we typed in when we did the wizard. This is the name of the ABI. This is the start block. And this is how we're going to process the data. So we're going to use WebAssembly, assembly script. We are going to use a certain API version, which is the latest API version. We're going to listen to all the Ethereum events. And then we're going to use the entities. So here we can see there's lots of entities. That's because this smart contract has all the stuff that comes with an NFT. And then it also has some custom stuff as well, like punk transfer, punk offered, punk bid, punk withdrawn, punk bought. So every time someone does something with a contract, they've emitted this kind of unique event, right? So it's basically a marketplace. There's a marketplace aspect to this NFT. And then we can look down below and we can see the handlers. So basically for every single entity, you'll also have a handler, right? So again, we can think of the entities as how we want to store the data, and the handlers is what data types are going to be passed to the handler in WebAssembly. So in this case, we have the, let's just use the transfer because this is probably the most popular one. If someone transfers a punk from one person to another, they would transfer it. So there's a handle transfer option or event handler, and it takes in an address, another address, and an unsigned integer. So these are the data types of the data that's coming off of the event. That's important because if you want to read in the data type, you need to know what it is to store it into Postgres so that you can query it later. And so this is how you define these data types. So again, it does everything for you out of the box. That's pretty much it. And then it tells you where the handler sits, which we'll get to in a second. And it tells you where the, where's the entities? Right here, schema. So this is the entities. So entities and schema are kind of the same thing. And then handlers and mappings are kind of the same thing as well. I don't know why they call them the same thing, but okay. So now let's look at the schema. So as we said, we have, for every event, we have a separate schema. So what's important about this is that, again, we talk about the data types. So the data types need to be correct and how you want to store the data. And it doesn't mean that the event, like let's say you're storing data that comes off of a smart contract. It could be, maybe it's an integer and you want to convert it to a string. That's fine. You can do that in the handler, but these should be exactly how you want to store the data. So this is very important. It's just how you store the data. So you can see there's ID, which should always be bytes. There's an to address, which also is bytes because it's an Ethereum address. The index is an integer. In this case, it's an unsigned integer. And then there's other things like the block number, which comes from the block, and the timestamp, which is the time that the transfer happened or the assign. And then there's the transaction hash, which is similar to the address, but it looks a little different, but it's the hash and it's a little longer. It's the hash of the entire transaction. So that's how we want to store the data. So we have one of these for every single event in this contract that was automatically built for us, which is great. Okay, so we have the high level configuration here. We have the schema here. The next thing is the source file, which has the contracts. The handlers. So again, this looks very similar to TypeScript. So if you've ever worked with TypeScript, you'll kind of see like, oh, it looks very similar. It's a subset of TypeScript. And it does things like the top is like we import the contract, like the generated types for the contract. Like basically these are the events and what the types look like. And then we import the schema. So we do what the data looks like from a TypeScript perspective that's been generated and what it looks like to store the data in the schema. So we do that for both. We can see we import those. And then there's these functions, which are the handlers. A handler is essentially a function that does something. So let's look at the transfer. So there's handle transfer. So this is exactly what we want to do. We want to say that, okay, every time that a transfer happens, we want to handle that transfer. We want to take in an event and look at that event as the transfer event, which comes in up here at the top. Okay. And we also want to, if that event has never, if that entity or the way we want to store that has ever happened before, then we want to create a new one, essentially. So this is going to create a new entry into our entity or into our schema. And we're going to create the entity value as the hash using concat I32 of the event log index. And we're going to convert it to I32. So there's some weird conversion stuff that happens here. It's not too important, but you'll just find out that you might have to like convert your data as it's coming from the events to the proper format to store it the right way. And in this case, we want to do bytes. So we're storing this as bytes, I believe. Let me just double check. Yeah, it's bytes. So we need to do that here to concat the I32. And then we also take in the event parameters that come off of the smart contracts event. So in this case, we have a to field, like who was the punk sent to? What was the index of the punk? So what number was it? Was it punk number 1? Was it punk number 10,000? And then we also get the information from the block. So we say, well, what was the block number? And we set that. What was the timestamp? We set that. And then what was the hash? And then we set that. And then the last thing is we save it. Okay, so we save that into Postgres. So the indexers are running this for you, and they're running this handler, and basically it gets compiled down into WebAssembly, and it runs in a secure environment, and it stores the data for you in this nice way. So I know that can be a lot when you first learn, but the cool thing is that, again, it's out of the box, it's going to build it for you. I want to take a second just to talk about what we'd like to see for you guys when you're hacking. This is great. If you write a smart contract and that smart contract has events, that's good. You should create a subgraph using the CLI, use the init, and have it create it. We want to see you guys do more interesting stuff here inside of assembly script. So in other words, like let's say you want to keep track of like the number of times that a transfers happen on a specific punk, right? Or you want to keep track of maybe the TVL, like the cost of the punk. How much does it cost to actually buy that punk at the time? Maybe you want to get more interesting data. And then you can start expanding your schema, add more to your schema, get more information. The more rich your smart contract event is, the more interesting data that you can get and process. So just think about ways that you can organize the data in an interesting way and just try to push the boundaries of the subgraph while also keeping it very optimized. And a lot of this stuff is in the README and the docs, so you should be good. Okay, so now let's deploy our subgraph. So we have the subgraph all scaffolded out. It's ready to go. The last step is we just need to deploy it. So let's click that and let's deploy it. So it's going to take the configuration and it's going to publish it to the network. It's going to publish it to a development environment. But yeah, we'll get to that in a second. It's going to ask you what version you want to use. So in this case, it's our very first version. So we could do 0.0.1 and hit enter. It's going to go through, compile it one more time, make sure it's compiled, and then it's going to publish it for you and send it off. And it's going to give you this unique URL that you can go to query. So if we went there, let's grab it. And it's going to give you a graph. This is Yoga GraphIQL, which is a GraphQL Explorer, which lets you just kind of start playing with the data. So you can do it here, or you can do it right in the studio. Now, if we look here, we can come here and we can go to Playground, and we can start seeing that we can see here that it's syncing right here, and it's at 19%, which is surprising to me because I would think that this subgraph has been deployed again. If it detects that it's been deployed already, it will go to 100%. It might do that at some point here, we'll see. But what I want to show you is that we can go to the logs, and we can see here that it's starting to do some stuff with the data. It's processing stuff. You can see here. And we can come to the playground, and I think we should be able to hit play. We might not get data yet. Yeah, so it's not available yet. It takes about, oh, there it goes, entity count 10,000. So it's already started to index data. So it's got 10,000 entities. Let me make this a little bigger too. Okay, so let's try to get some data. So let's go to this little tab right here. So what I always like to show off is this. Because we're using a schema, we can go through and search the data really easily. So we have all of the entities here, and we can see the transfers and the punks bots. And so we can look through and find the data we care about. So let's say we want to get the transfers, we get the first 5. We can order them by the timestamp of the block. We can change the order from ascending to descending. And you can see here, it's just going to build out the GraphQL query for you. This is really nice because you can just come in here and say what exactly you want. So I want the block number, I want the timestamp, I want the hash, or maybe I don't want any of that stuff. Maybe I just want the from and the to and the value. Let's just do the block number, sure, and then hit play. There we go. So I was able to just hit play, get the data I care about, and then have that. So you can see here that we have a data object. It has a transfers array, and then it has the ID, the from, the to, the value that was transmitted, and the block number. So it's really useful. Then we could just plug this into our front end using any kind of GraphQL query framework. If you want to learn about how to query the data in your front end, the Subgraph package has an example in there that you can do. So that's going to show you, and it uses Apollo. But there's also other ways. There's Graph Clients, which is another way. There's many GraphQL query frameworks, but once you start building your application, you'll make a decision on what you want to build. But yeah, so you can see here now it's at 21%. The indexing is happening, and at this point, it's kind of ready to go. Okay, so let's see, what else can I show you? Okay, so when you go to the Details tab, you can also see your development URL. You can see you can either get the specific version here, or you can do this the latest, which is really useful. And this would be the URL that you can put in your front end to start testing, right? And it also gives you the deployment ID, tells you how long ago it was deployed, and that's it. And so now if you came over here and you made some changes, like let's say you came in and you wanted to make some kind of change, then you could just come in here, redo the code gen and graph build, and redo the deploy. And then let's say you deployed again, you could change the version, 0.0.2, hit enter, and then you'll have a new version of the subgraph. So basically every time you make a change to your smart contract events, those are going to change. So probably your subgraph needs to change. So that's kind of like the development lifecycle as you build your smart contract, emit the events, create a subgraph, index those events, and then use that data in your front end in a easy to query way. So let's say you want to get help. So at this point, you've started building. Go to the docs. The docs are really good. They go through all this stuff that I just showed. They talk more in depth about it probably, and you can kind of dig in here. There's a search function. Like let's say you want to search about something. I don't know. You want to learn about handlers, what types of handlers there are. There's call handlers. There's block handlers. Sure. How do you get transaction receipts? That might be something you'd be interested in. So there's lots of information in here. So if you start kind of building and thinking about what you want to do, the docs can be a little like overwhelming at first because there's lots of data in there, but they're pretty good, and you should be able to find everything you need. There's also lots of YouTube videos. So if you go to YouTube and you go to the graph, and you could do like the graph development, something like that. There's lots of workshops that me, Marcus, and Simone have done. This one's really good, full stack development workshop with the graph. That one I go talk about scaffold ETH. There's lots of graph builders office hours as well that you can watch where people come on and show off stuff they're doing in the graph ecosystem, might give you some ideas. Yeah, so there's lots on YouTube. So definitely look that up. Cool, I think I hit the perfect time to stop and ask questions. So I'd like to just kind of take a second and just give you guys the floor and see if you guys have any questions.
Exactly. Yeah, great. So thank you for the comprehensive explanation in the live demo. It will definitely help the builders. Even for me, like I'm not an engineer, but I start feeling I can do subgraphs. Okay, so yeah, we got some questions on the YouTube, so let me read them and ask to you. So the first question is from Tran. I have a question. What happens when we publish our deployed graph? Is it necessary?
That's a great question, and I didn't really cover that, but the idea is you deploy your subgraph to the network, to the development environment. When you actually want to publish it, it's probably in a state where you're going to use it in an application, right? And so this is going to allow you, when you publish it to the network, you can pay a little bit of GRT. So basically you pay GRT so that an indexer will pick it up and index it for you. So it's kind of like, okay, hey, I have this subgraph that's very important to me. I'm going to pay a little money. It's kind of like if you were to pay Google Cloud or, pay AWS, but instead you're paying the network, and the network says, oh, okay, I'll take some of that GRT and store it for you and make it available. So it's kind of like you're curating your own subgraph and making it publicly available. And then you can query against it on a production level, which is like fast response time, no rate limiting. It's not a development environment. It's like, okay, I've built my dApp.
Great, thank you. So let me go to the next question. So next one is from Jin. The graph supports only EVM compatible chains? That's the question.
So you can actually go on and see the entire list of supported chains. There's other chains that are not EVM. So if you just do the graph supported networks, I think this one might have been in a doc or something that was shared by WaveHack, but there's a full list here, and they're all here. I'm just trying to think, like Near is one of the ones that's on there. Cosmos. We also support Bitcoin, which is funny. We index Bitcoin data, which is really cool. And Arweave, which is like a file sharing, more related. But I would say majority of our traffic probably comes from EVM stuff. And I think it's probably the most exciting to build on. So, and probably the easiest to build on. So, good question.
Yeah. Great. So everyone, please check this page for the supported networks and choose the right one, which is the best one. And the next question is from the Jin as well. What kind of products in WaveHack Global do you think would be especially good to rate highly? Yeah, so he definitely wants to get a grant. So could you probably give him some idea and, if possible, show some example of the existing subgraphs you think it's a cool?
Yeah, so I kind of go back to, I can actually show, like, if we go to like the Subgraph Studio, or sorry, Explorer, and we look at like a subgraph, actually the most, I would say the best subgraph you can look at to get an idea of like quality is actually the CryptoPunks subgraph here. I think this is the one, which if you come here, you can kind of see, is this the one? Yeah, Jerry Okolo. He actually works for the Edgen node. He works on the graph now, which is great. I think he actually wrote this before he worked here. But it is good to go through some of the like really popular subgraphs and see how they write the code and see how they process the data. And that's what's most important to us. If you have a cool idea, that's nice too. So if you want to build a dApp that's solving a problem, a general use case, that's like definitely bonus points. But what we really want to see is like how you're organizing the data, how you're processing the data. Are you doing it in an interesting way? And so you can kind of look at some of these other examples where, people are doing interesting ways to process the data, tag it properly, have good documentation, different things. And so this one's a really good one to look at. But yeah, I think if we were talking about ideas, I really like stuff in the public good space. So people that are doing things that maybe help fund developers. I think that's there's a lot of interesting stuff that can be happening with there. What else? I'm also very interested in like the SocialFi stuff. I think there's some interesting stuff that can be done with like social media and smart contracts. I think there's a lot of interesting ideas there. What else? Yeah, there's so many ideas you could do. Decentralized, something like a decentralized GitHub. I know there's a couple projects that do that, but it'd be cool to see more in that space. More things around like censorship resistance, decentralization, focused on decentralization, focused on some of the core stuff that we care about.
Yeah, great. This part is kind of one of the most important part of this session, probably. And this online session will be recorded and published right after the live. So yeah, everyone can review what Kevin said. And the next question, is there any way to simulate gas fee of a specific contract using the graph?
No, there's probably a way for you to get the values and store them. You could probably do something there, but you would need to probably use substreams, which is a more advanced way of processing data. But substreams would be the way to do it if you want to store the gas values that are happening. Like if you wanted to maybe make like a historical value about what the gas cost for all the transactions, and that would be something you'd have to use substreams for. You can look more about substreams. There's lots of videos on it, but there's no substreams bounty, but you could do a substreams powered subgraph to do that, but it's very difficult because you need to write in Rust. But Scaffold.eth does some contract gas estimations for you as well, or it will tell you exactly how much gas it costs. So that can be a really good gauge. So if you use Scaffold.eth, deploy your contract with that, and it will show you how much gas. And you can also fork networks with Scaffold.eth because it uses Hardhat, and it will also tell you how much gas that it's going to cost, at least roughly.
Got it. Thank you. And can I add one question from myself?
Yeah, absolutely.
Yeah. So as I said, I'm not an engineer based, but if I'm interested in building the subgraph actually, so if I want to build something in the blockchain field for the first time for the graph, which chain probably should I use? Should I choose to build a subgraph?
Yeah, I would probably try to identify like a new protocol that just came out, because there's probably not a subgraph already written for it. So it would be a challenge. So I would look at like Ethereum mainnet, maybe look at Base. There's lots of transactions there's lots of smart contracts being deployed on Base right now, because Base was like super cheap because of the recent blobs that were enabled. So I would look at maybe some of the meme coins. They're actually kind of cool. There's a lot of interesting new meme coins that are popping up on there. So try to find like newer contracts, because it's a challenge. And you could try to look at maybe older contracts and then implement some of those changes. Also, like if you find a really old subgraph, like if you could find an old subgraph that maybe has not been upgraded in like a long time, and if you go through and actually update that subgraph, that's really cool as well, because it teaches you like, oh, like I could have done this, like this person could have done this better, and like try to improve their subgraph. That's also another interesting thing that I see often. And it's a really good way to learn. And bonus points if you also update the smart contract and deploy your own version of it, because then you can like, start to do interesting stuff there as well and improve the Solidity code or whatnot.
Nice. Got it. Thanks for the great input. So yeah, it's almost time for the conclusion of this online session. But Kevin, do you have anything you would like to say to the developers or the potential WaveHack Global submitters?
Yeah, I would just say that all of you are very important to the community. Really excited to see what you guys build, and I hope to see you guys in Tokyo sometime soon, maybe at EdCon. I'm going to try to come to EdCon. But yeah, just really be passionate about what you're doing, and just get excited and build something that you care about, and you'll probably go places and go somewhere in the ecosystem. So stay positive and just keep at it.
Yeah, exactly. So thank you very much, Kevin. And thank you everyone for your active participation in today's session. Special thanks for the Kevin, of course, and for the insightful presentation and answering our questions, including my questions as well. It was a fantastic opportunity to delve deeper into the graph and understand its people's role in the blockchain ecosystem. As we wrap up, I encourage everyone to keep exploring the possibilities with the graph, especially focusing on the build theme we discussed. Remember, the best new subgraph is the grant pool. It's not just a chance to win a grant, but also an opportunity to contribute to a vibrant and growing community. Please keep an eye on the Luma page and our upcoming sessions for more resources and support as you build your projects. If you have any further questions or need guidance, feedbacks, don't hesitate to reach out through our official channels, such as X and Discord, and of course, the Subgraphs community. Yeah. Thank you once again for joining us today. We hope to see you at our next session and your submission to the WaveHack Global. Yep. Have a great day, everyone. じゃあ、金城さん、これで、
Yeah.
完了で。はい。
Hi, thank you for everyone. Thank you for coming. Yeah, let's keep building on on the graph. Yeah, so thank you for coming. Bye bye.
はい、ありがとうございます。
ありがとうございます。